Welcome to Quanta Magazine's podcast. Each episode, we bring you stories about developments in science and mathematics. I'm Susan Vallet. In early 2016, two planetary scientists declared that a ghost planet is hiding in the depths of the solar system, well beyond the orbit of Pluto. They based their claim on the curious orbits of distant icy worlds, and the claim quickly sparked a race to find so-called Planet 9. Planet 9 is estimated to be about 10 times the mass of Earth. Gregory Laughlin, an astronomer at Yale University, says it's hard to get a real handle on what's going on with Planet 9.
There's a very elusive planet that has this kind of real magnetism to it. Finding a 10 Earth mass planet in our own solar system would be a discovery of unrivaled scientific magnitude.
Now, astronomers say they've spotted another distant world. It could be as large as a dwarf planet, and its orbit is so odd that it's likely to have been shepherded by Planet 9. The object confirms a specific prediction made by Konstantin Batygin and Michael Brown. They're the astronomers at Caltech who first argued for Planet 9's existence. David Gerdes is an astronomer at the University of Michigan who co-authored the new paper. He says it's not proof that Planet 9 exists.
But I would say, the presence of an object like this in our solar system bolsters the case somewhat for Planet 9.
Gerdes and his colleagues spotted the new object in data from the Dark Energy Survey. It's a project that probes the acceleration in the expansion of the universe. The project surveys a region well above the plane of the solar system. This makes it an unlikely tool for finding objects inside the solar system, since they mostly orbit within the plane. But that's exactly what makes the new object unusual. Its orbit is tilted 54 degrees with respect to the plane of the solar system. That caught Gerdes off guard.
We have been doing a general search for objects beyond Neptune in our data. And so the tools that we use to do that don't necessarily look for any specific kind of funny orbit, just any slow-moving object in an orbit around the sun will do. Having said that, we didn't expect to see anything this unusual because no one ever had an object that never crosses Neptune's orbit and has an inclination of over 50 degrees just hasn't been seen before. It's quite unique. And so I think it's a super exciting object for that reason, that you've got to explain how it got there. And it's certainly got an interesting story to tell.
But Konstantin Batygin and Michael Brown weren't surprised at all. 2 years ago, Batygin and Brown made a case for Planet 9's existence based on the peculiar orbits of a handful of distant worlds known as Kuiper Belt objects. That small population loops outward toward the same quadrant of the solar system. It's a phenomenon that would be extremely unlikely to happen by chance. Batygin and Brown argued that a ninth planet must be shepherding those worlds into their strange orbits. What's more, Batygin and Brown also predicted that over time, Planet 9's gravity would push these Kuiper Belt objects out of their current plane and into ever higher orbital inclinations. Batygin says they spotted this early on.
If you investigate what is the long-term effect of Planet 9 on this clustered set of distant Kuiper Belt objects, the fact that some of them get sort of taken out of the plane of the solar system and go on these long ride in inclination space where they get perturbed kind of on their sides and appear very, very much inclined with respect to the rest of the solar system. And we had a kind of hint of the fact that that was happening already in the data.
Astronomers have already spotted a bizarre population of worlds that orbit the sun perpendicularly to the plane of the solar system, but they had never caught an object transitioning between the two populations. Batygin says the new object fits so perfectly with their model that it almost looks like one of the data points in their simulations.
A good theory reproduces data, but a great theory predicts new data.
The Dark Energy Survey first detected evidence for the new object in late 2014. Gerdes and his colleagues have spent the years since then tracking its orbit and trying to understand its origins. In the recent study, they describe how they ran many simulations of the object within the known solar system, letting the clock run forward and backward 4.5 billion years at a time. Nothing could explain how the object landed in such a tilted orbit. They finally added in a 9th planet, one with characteristics that perfectly match Batygin and Brown's predictions. Then the wacky orbit made sense. Here's Konstantin Batygin.
This object, I think, represents the first true confirmation of the predictions that we made. With this object in the bag, given that there's no other reasonable way to populate the Kuiper belt with such highly inclined bodies, I think the case for the existence of Planet 9 is now genuinely excellent. Of course, Planet 9 still has to be confirmed observationally.
Juliet Becker is a graduate student at the University of Michigan. She's the lead author on the new paper.
What we found that was remarkable was that the second you put Planet 9 in the simulation, not only can you form objects like this object, but you absolutely do form these highly inclined, highly eccentric orbits. Like, it's very easy. So it's very easy to make objects like this if Planet 9 is in the solar system. If Planet 9 is not in the solar system, I can't say it's impossible, but our simulation results show that it is a lot more difficult.
Other astronomers aren't so certain, in part because the early solar system remains a mystery. Scientists suspect that the sun was born within a cluster of stars. That means the early planets might have had many close encounters with other stars that sent them on paths that seem impossible today. And even once the stars dispersed, the early solar system likely contained tens of thousands of dwarf planets. Those could have provided the gravitational nudges needed to push the object now known as 2015 BP 519 into such an odd orbit. Michelle Bannister is an astronomer at Queen's University, Belfast, who wasn't involved in the study.
In terms of why it's exciting, it's like, we're finding out that there could be a way for the solar system's history to have unfolded that simply we'd never even thought of before. To me, Planet 9 is one of a number of ways that the solar system could have unfolded, and it's a potential idea.
Yet, when astronomers examine the larger universe, the idea doesn't seem all that surprising. Planets between 2 and 10 times the mass of Earth are incredibly common throughout the galaxy, which makes it odd that our solar system doesn't have one. Yale astronomer Gregory Laughlin says since we know distant planets in other solar systems are a reality, there's nothing intrinsically weird about Planet 9.
If it wasn't in our own solar system, if the stakes weren't so high, I think that the hypothesis would be almost certain to be correct. It's only the fact that it's so amazing that tends to give me pause.
Laughlin says finding a 9th planet within our solar system would be both transformative and extraordinarily inspiring. Michelle Yoon helped with this episode. I'm Susan Vallet. For more on this story, read Shannon Hall's full article, A New World's Extraordinary Orbit Points to Planet 9, on our website, quantamagazine.org. Also, the MIT Press has published 2 quanta books, Alice and Bob Meet the Wall of Fire and The Prime Number Conspiracy. Available now at Amazon.com, BarnesandNoble.com, or your local bookstore.